All right, we're trying something different. We're trying to use the Smartboard or the Promethean board today. What I want to do is I want to talk to you guys about lesson 6, day 2, expanding binomial expressions. Some of this may sound familiar. Some of this is going to be a reminder of things that you need to know how to do. And let's just start off with the intro task A, where it says determine which of the following expressions are equivalent. And so if I look at the order of operations, which says P for parentheses exponents, multiply, divide, etc., add, subtract. The first thing that we're going to do with A is we're going to combine the stuff in parentheses by 10 minus 2, that gives us an 8. It's still in parentheses, but it's only a number, so we're just going to multiply 5 times 8, and the answer is 40. That is, bizarrely, a big thing. Okay, you're going to see me as I'm trying to get this thing tried out. I'm going to move on and try a different one here. So in this one, maybe that's where it is. Yes. Okay, come here, you. Not so much. There we go. So in this one we have 5 times 10 and 5 times 2. Because there are no parentheses, there's no grouping operations for us to do. And so the thing that I want to be able to do is do 50. 5 times 10 is 50, and 5 times 2 is 10. So I'm doing the multiplication first. 50 minus 10, also 40. We already know the answer to the option 3, or letter C. 5 times 8 is 40. And this one over here, kind of weird. 2 times 18 plus 2 times 2. Looking at different ways that we can rewrite the information that we've been given. So in this problem, 2 times 18 is 36, and 2 times 2 is 4. And so therefore the answer to letter D is 40. Oh, look at that. They're all an answer of 40. Must have been done intentionally. There are several different ways for you to be able to evaluate an expression, and they all have something in common. Take a look at how they all have a 5 in common, a 5 in common, a 5. Where's the 5 in this one? Maybe that'll be the objective, is to figure out where the 5 is in that problem, or just see how it connects to everything else. Let's take a look at some examples. The distributive property is the focus for this lesson, combining like terms and looking at how you can simplify and expand information. And so in this problem, one thing that I'm going to recommend is something called the area model. The area model meaning we're going to draw a rectangle, and along the edges of the rectangle are going to be these terms. We call them terms. We call them factors. And so we're going to be looking at how those things are interacting with each other. Maybe somewhat of a review. But I'm going to take, for example, I'm going to take this -3. I'm going to make it be the edge of that box. I hope I'm clear with this representation that it's an area of a rectangle, and so that means length times width. The other thing we're going to use is this a minus 5 to separate the box into 2 sections. There's a section where -3 is multiplying a because that's length times width. And there's a section of the box where we're taking -3 times 5. And that makes negative times a negative is a positive, so that makes positive 15. So therefore, for number 1, the distributive property, we're taking this number, this factor or term that's on the outside, and we're placing it, or multiplying it, to these 2 things that were in the parentheses of the other thing. And a full simplify, take everything in the box, -3a plus 15. That's going to be our answer for number 1. Number 2 looks exactly the same. Getting the idea down, first of all, that we can use a rectangle picture in order to figure out how to expand or distribute what's going on. So I'm going to start with the rectangle. And you don't have to do the rectangle eventually. This is kind of just like the structure or setup. And if this is familiar and you say like I learned it a different way, cool. I'm going to try to get to at least another way to show this. But the 2x factor, because it's, just one thing, I'm going to put it on the small side of the rectangle. And the x minus 4 factor, I'm going to put along the top. So x minus 4 is this length edge of the box, and 2x is this width edge of the box. And then the x minus 4 splits the box into 2 sections because there are 1, 2 terms. Now taking x minus 4 and multiplying each of them by x, so 2x times x, I'm going to get the area of that little rectangle, 2x times x, 2x times x. I have a simplified answer in a second, but I just want you to see it's the 2x times the x. And then taking the 2x and the negative 4 and multiplying them together, I get 2x times negative 4. So taking the left half and the right half and combining them with addition, the final answer will be 2x, wait, there's two x's, and they're multiplied. That means we're squaring. X times x is squared. The 2 is not squared, but the x is. And then 2x, oops, there we go, 2x times negative 4. Well, negative 4 times 2 is negative 8, so we're going to multiply the numbers together. And then the variable x, it's not able to be combined with the numbers, but it does hang on at the end. So put the x right there, and that's the answer. There is a shortcut way, and the shortcut way I'll get down to in the practice section. So I'll leave that alone for a second. The shortcut is coming. The shortcut is like not doing the box method, but I want you to see the box method, or we call it area model. Continue. I'm going to maybe go a little bit faster through 3, and then I'm not going to explain so much. I'm just going to go out. Box, negative 3x squared, 1, 2, 3. There are 1, 2, 3 terms. So for those 1, 2, 3 terms, we're able to do 2x squared. Oh, I don't like that. Let's go back here. And come on now. There we go. Okay. And negative 5x and 4. So if the number right here, if there's a minus sign, it means subtraction. Yes, it means take away. But it's also the same as just give it to the 5. Make the 5 be negative. And so that's why I've got the minus sign there. I don't really need to put a plus sign on the 4. 4 is positive. We'll save the plus signs as combining operations for the expression when we get there. But multiply the numbers, the coefficients meaning multiply negative 3 times 2. And then this is where properties of exponents is important. The fact is you have x squared times x squared. X squared times x squared means you have 2 x's, and then you bring in 2 more x's, so you have 4 x's. So we would write x to the 4th. Continue with that because in the next 2 terms that we multiply, we're multiplying the coefficients. Those are the numbers negative 3 and negative 5. A negative times a negative is a positive. So a negative 3 times a negative 5 is a positive 15. And then there's x squared times x. So we have 2 x's, that's in the width of the rectangle, and 1 x means that we have x to the 3rd in that box. And that's the area of this middle section. The last section is to take the width and multiply it this little segment length of 4. So negative 3x squared times 4, multiply the coefficients, that's the numbers, and then bring along the variables and deal the math of them later. So negative 3 times 4 is negative 12. Again, I guess you got to reset all my settings. Okay, and then x squared, this 4 doesn't technically have, oh, it does technically have an x. It has x to the 0. You know, anything to the 0 power is 1, so 4x to the 0 is technically the same as just 4 times 1, 4. So if I have 2 x's over here, and I have no x's over on the left, that means I still have 2 x's, so I still have to have x squared. Using the area model, all of them gives me the answer, negative 6x squared plus, whoops, what's my eraser button? Erase. Ooh, that's kind of fun. Go away, good. To the 4th plus 15x to the 3rd minus 12x squared. There is the answer. If we can see it on the screen, I didn't really do any calibration of the video. But the point is, this is the expression for negative 6x to the 4th. This is the answer to multiplying these 2 factors together. No area model this time. Using just a demonstration of how I connect. I'm connecting these 2 together. I drew the arrow in the wrong spot. I'm connecting those together. I'm connecting those together. I'm connecting those together. So the distribution, the give out the term to everything, tells me that I'm going to take 3x squared and multiply to everything that's there. So like the 5y. 5y is going to be multiplied to 3x, and 5y is going to be multiplied to negative 6y. Without the area model, just by thinking about connections that can be made, I'm going to multiply coefficients, and then I'm going to put the variables together cleverly. So if I take 5y and I distribute, meaning give it through multiplication to the first term, I'd have 5y times 3x. I'm going to use parentheses for multiply, and then I'm going to take that, just kind of set it to the side, and then I'm going to take 5y and I'm going to multiply it to negative 6y. 5y times negative 6y, so add to that 5y times negative 6y. So I'm looking at two separate terms, and in these two separate terms, I'm still going to do the same thing. I'm going to multiply the numbers and cleverly combine the exponents, or the variables. So 5 times 3, 15. And then x and y are different variables. So instead of thinking about is it x squared, is it y, what goes where, we just put them together, x, y. It's put together with multiplication, so technically, you know, times and times, that's not necessary. But the things that are there, if you see a number and a letter next to each other, we know that means multiply. The last part, plus 5, so it's positive, and a negative 6, must be negative. Positive times a negative means that I'm going to be subtracting. Positive times a negative is negative, and that is represented with subtracting 5 times 6. And then here I have to think about the variables. I have 1y over here, I have 1y over on the 6, and when my final answer happens, I have y squared. So answer is, survey says, the answer for number 4, 15xy minus 30y squared. I'm going to box it so you can at least see it pop out on the screen. I'll do one more. I'll do these two right here, and then it's your job. I'll say that this is extra. No, I don't want to do that. Okay, I want to say that this is extra practice. Like you should do that. And this is extra practice. But let me do letter C with you. Letter C with the minus sign is technically like I've written minus 1 in front of the whole thing. So I could draw a box area model and show that minus 1 is multiplying 4x. So it just makes negative 4x. I could say that minus 1 is multiplying to the 10, which makes minus 10. Nothing left to do for that one. That is the answer. Think about how you'll use that with letter A. Whoa, with pen only, letter A. Let me do this last one. I got one last minute before I'm going to say, hey, that's it, you're done, do whatever you got to do. 12x times 3y. If I use the box method, then I'm showing how on the outside of the box is 12x, and on the inside of the box is 3y, 3x. But in other words, what I'm saying is this 12x is going to multiply to the 3y. You're taking length and width of a smaller rectangle made by this bigger expression. 12 times 3, and x times y just makes xy. So that's what I would get, 36xy. If I look at 12x times 3x, 12 times 3, and then x times x, 1x, bring them together, x squared. And so that's the same as if I take 12x and distribute it to the 3x. So 12 times 3, x times x gives us 36x squared. Boom. That's our distributive property in action. Please give it a practice with A and B. To rewrite the expression really does mean apply the mathematics. Maybe you want to like not multiply it yet out, like I did right here. Ooh, not there, pen. Like I did right here. That might be another way to rewrite it and then multiply and simplify, but that's the distributive property in action. Okay, that's the bell. Stopping.